Right, so we're going to be looking now at right-angled trig questions. And the first thing and the most important thing you need to check before you actually start is that your calculator is actually working in degrees. And in order to make sure that's the case, that I'm pointing to there should be a little d. If it isn't, then you need to go into the setup, which would be shift and setup, and make sure that you select 3 there for degrees. Okay, so that's crucial. That's the calculator is going to be working in the right angle measure before you start. Right, the way probably you will have been taught to remember the trig ratios is in triangle form, where you've got sine, SOH, so, cos, CAH, car, and tan, TOA, toa. So car toa, or some people silly old Harry, others, some officers have curly auburn hair. However you remember it, doesn't matter, but you aren't given those relationships, you need to remember them. If you can remember them in the triangle form, then that is really helpful, because that actually sorts out for you when you're multiplying and when you're dividing in order to answer the questions. So we'll come back to those as we go along. Usually on a higher tier paper, a trig question is given in some form of a context. In this first question that we're going to look at, we've got a vertical post AB. AB is 15 meters from a point C on horizontal ground, so that's 15. The angle of elevation of the top of the post from the point C is 67 degrees. Angle of elevation is the angle that your eye would turn to through even if it was going from looking horizontally, and the angle it would turn to look up at something. That angle is angle of elevation. Okay, so I've read the question carefully and I've taken that information and I can see where it is relative on the diagram that's been drawn for me. And I want to find the height of the post. So what I'm looking for is this distance here, AB. Now with any right angle trig question, the first thing that we do is we label our sides, which is opposite, which is hypotenuse, which is adjacent. The opposite is always the one that's directly opposite either the angle we're given or the angle we're trying to find. Now we're not trying to find an angle in this question, we're given an angle and this is what we're trying to find. So this is our opposite side on the triangle. The hypotenuse is always directly opposite the right angle. It's also always the longest side. So the right angle points to the hypotenuse, so that's my hypotenuse, and then the adjacent is the remaining side. Okay, so I've labelled my 3 sides of the triangle. What I now need to do is look at including which of these 3 relationships includes the side that I'm trying to find, the opposite, and includes a side that I know, which is the adjacent. So I'm looking for the ratio that links O and A. And I can see there that the one that has O and A in is the tan one. So this is the one that we're going to be using. So if I just write that there, then I know that that's what I'm dealing with. And what you then do is you cover up the side or the angle that you're trying to find. I'm trying to find the opposite, which means the T and the A are on the same level in the triangle, so that means that they're going to be multiplied together. So the opposite is going to be the tan of the angle times the adjacent. Okay, so opposite is tan of our angle, which is 67 degrees, times the adjacent. Okay, well the opposite is what I'm trying to find, AB, which is going to be tan of 67 multiplied by 15. Now on my calculator, I type that in exactly as I see it there. So tan is that button of 67 Now I now need to close that bracket to say that I've finished with the angle bit, and then times by 15 and press equals. So the height of the post, if we give it to 1 decimal place, is going to be 35.3. Just check the next digit along. It's smaller than 5, so it remains as 35.3, and the units in this case are meters. Part B, they're not giving you the diagram, so you have to do a little sketch of the diagram yourself. So what have we got? We've got a ladder which is 21 meter long, placed against a vertical wall. So if you've got a vertical wall, that means that the angle between the wall and the ground is a right angle, vertical and horizontal. We've got a ladder which is 21 meters long, placed against the vertical wall. So it's going to do that. There's my ladder, and I know that the ladder is 21 meters long. The foot of the ladder is 13 meters from the wall on horizontal ground. So the distance from the wall to the base of the ladder is 13 meters. And I'm interested in the angle which the ladder makes with the horizontal. So the ladder is there, the horizontal is there, so it's this angle that I'm trying to find. So if I call that x, I know that that's the angle that I'm trying to find. Now we do exactly the same as before. We label our sides. This time, opposite is opposite the angle we're trying to find. So there's our opposite. The hypotenuse, again, is opposite the right angle, and what we're left with is the adjacent. So this time, when I'm deciding which of my three ratios to use, which of those three, I need to find again the one which I know two parts of, and in this question I know the adjacent and the hypotenuse. The adjacent and the hypotenuse is linked with cos. Okay, so if we just put that down here, I know that I'm going to be using the right one. Now, if it's the angle I'm trying to find, then the angle is linked to the cos, sine or tan bit of it. So I'm trying to find cos, which means it's a over h. So I'll write that here. Cos of x, what I'm trying to find, is a over adj over hypotenuse. Okay, so cos of x is the adjacent, which I know is 13, divided by the hypotenuse, which I know is 21. Now, in order to get the angle, I need to undo the cos. I need to get rid of the cos bit. And the way that we get rid of the cos bit is we do the inverse of cos. And that's written as cos with a little minus 1, and then 12 over 21. Now if you have a look at your calculator, above the sine, cos and tan buttons, you've got the sine with a little minus 1, the cos with a little minus 1, and the tan with a little minus 1. So to get at those, you use shift and then press the appropriate one. So in order to work out our angle, I can now type that on my calculator exactly as I see it there. So let me just see if I can get this better in the light. There you go. So calculate the last, cancel the last calculation. Shift and cos gives me the cos minus 1. And then if I press the fraction button, I got the 13 on the top, move the cursor down, 21 on the bottom, move the cursor across, close bracket. So that looks exactly the same as I've written it. So I'm confident that when that works out, 51 point. And again, if it doesn't tell me what angle, what degree of accuracy, we'd go to 1 decimal place. To 1 decimal place, that would be 51.7. But the next one along is 5. If it's 5 or more, it rounds up. So what we're going to write down is 51.8. 51.8 degrees. So there's 6 marks there for those two parts of that question. First part, you're finding an unknown side. Second part, you're finding an unknown angle. Okay, so let's look at the context for this question. In the diagram, ABC is a straight line, ABC. A line BDE is a straight line perpendicular to it. Perpendicular means at right angles, so there's one right angle, and I'm going to have another right angle there. It is given that AD is 36, so from A to D is 36, from B to C is 49, from B to C is 49, angle DAB, D to A to B, so that angle is 43, and E to C to B is 54. And we have to find the length of DE. So we're looking for this distance from here to here. And in order to do that, we have to go 2 stages, because there's not enough information straight away from one of these triangles in order to work out what that particular distance is. Okay, so what we've got here then is, in this triangle, we've got enough information with that angle and that side to work out what DB is. In this right angle triangle, we've got enough information to work out what BE is. So once I know the distance from there to there and the distance from there to there, then the difference between the two is going to be DE. So that's what we have to do. So in this triangle, so I'll work in red in this triangle. If I label my sides, there's the angle I'm given. So here is my opposite, here is my hypotenuse, and I don't know anything about my adjacent. So in order to find BD, I'm going to be using opposite and hypotenuse and that angle. So if I go back to my 3 relationships, if I'm working with opposite and hypotenuse, it's the sine ratio that I'm going to be using. So I'll just write that down first of all. So there's SOH. Okay, so I'm trying to find the opposite. So if I'm finding the opposite, it's going to be sine times the hypotenuse. So opposite will be sine of 43 times the hypotenuse. Opposite is dB, it's what we're trying to find. So that will be sine 43 times, and our hypotenuse we know is 36. So putting that into our calculator, again exactly as we see it, we're going to have sine 43, close the bracket to show we finished work with the angle, times 36, and that equals 24 point, and the 1 decimal place is 5, the next one is 5 or more, so that rounds up to 24.6 meters. So we know that from D to B is 24.6. Now we're going to work with this large triangle to find BE. So in this triangle, I know that this side is opposite, I know that this side is hypotenuse, and I know that this side is adjacent. So again, returning to our ratios, I need to find the opposite, and I know the adjacent, so the triangle I'm going to be using is the tan triangle. So if I just write that down here, TOA, then I know, and the examiner knows, I'm trying to do the right thing. So I'm trying to find the opposite. So again, if I cover the opposite up, T and the A are on the same line, so they're joined by a multiply. So write that down. Opposite is going to be tan of 54 multiplied by the adjacent. Opposite in our case is BE, which is what we're trying to work out. Tan of 54 multiplied by the adjacent, which is 49. put that into our calculator. Tan 54 close bracket times 49 equals 67.4. Okay, so I now know that the total height from here to here is 67.4, and from D to B is 24.6. So to work out DE, I'm going to take those away. So DE is going to be 67.4, take away 24.6. So 67.4 take away 24.6 equals 42.8 meters. Okay, so what made that more difficult than the first question that we did was that we had to work out those stages that we had to do ourselves. There were 3 steps to go from the question to the answer, and we had to work out what those steps were ourselves. Okay, so let's take a look at this question then. So there's no words here really. What we've got is we've got 2 right angled triangles sitting on top of a rectangle, and what we're being asked to do is to find the angle, that unknown angle marked X. Well, in order to get at that angle marked X, I need to know 2 sides out of the 3 in that right angle triangle. Now, because that right angle triangle is sitting on top of this rectangle, and I know that from A to B is 15 centimeters, then that means that C to D must be 15 centimeters too. So I've got one side of the right angle triangle. Now, in order to get C to E, I know that that's part of this distance, 23 centimeters from E to B. But I don't know what the height of that rectangle is. So chances are I'm going to have to do some work with this right angle triangle in order to do that. And yes, I have enough information in this triangle. I know an angle is 56 degrees, and I know one of the other sides in order to find out that height DA. So let's label the angle, the sides in this triangle. Given 56, which means that's my opposite. This is the longest side, opposite the right angle, so that's my hypotenuse, and that's the adjacent. So I'm working with the opposite and the hypotenuse. Opposite and hypotenuse is the sine ratio. So let's just write that one down, SOH, and then I know, and the examiner knows I'm using the right relationship. I'm trying to find the opposite. Opposite is the top, so it's going to be sine of the angle times the hypotenuse. Op equals sine 56 times hyp. Op is dA, so what we're trying to find is going to be sine of 56 times the hypotenuse, which we know is 16. So on our calculator, sine 56 close bracket times 16 equals 13.3 to 1 decimal place. 3 because the next digit along is 5 or higher, so it rounds up. So we know that dA is 13.3 centimeters. So this means that from B to C is also 13.6 centimeters, and we can then work out that CE will be 23 centimeters less the 13.3. We know it's 23 from there to there. I know it's 13.3 from there to there. So the difference is going to be CE. 23 take away 13.3, 9.7. Okay, so I know that this is 9.7 centimeters, which is opposite the angle that we're trying to work out. I don't know anything about my hypotenuse, but I know that the adjacent is 15. So going back to my ratios, I need to have two sides that I know, which are the opposite and the adjacent. Opposite and adjacent are tan. So I now know that I'm going to be using the tan relationship. It's the angle I'm trying to find, which is linked to the word tan. So it's going to be opposite over adjacent. So tan of x is opposite over adjacent. Tan of x, put those in now because I know them, 9.7 over 15. And remember, to get at the angle, I'm going to do the opposite of tan, which we write as tan with a little -1 floating above it, 9.7 over 15. On your calculator, type it as you see it. Shift tan to get the little -1, fraction button, 9.7 on top, on the bottom 15, move the cursor over, close the bracket. It looks exactly same as what I've written. Press equals, and that's going to be 32.9 degrees. 9 because 8 is the first decimal place, the next digit is 5 or above, so it rounds up to 32.9 degrees. Okay, next question. So we've got two more to look at. This is a similar one again, where we're dealing with triangle within a triangle. So the context of this then, we've got a building which stands on a horizontal ground ABC. The point E is 23 meters below the top of the building along the vertical face. So from D to E is 23. The point C is 46 meters from the point B, so that's our horizontal distance there. Angle of elevation, the angle of turn from horizontal up to the point E is 37 degrees. And the first thing that we need to work out is the height of the building. Well, the height of the building, we know part of it, so within this lower right angle triangle here, we need to work out what the height, the distance BE is. Okay, so we label our sides. There's the angle we're dealing with, so this is opposite it, so BE is the opposite side. The hypotenuse is this one, which I've got no information on, and this one is the adjacent. So I'm working with opposite because I need to find it, and adjacent because I know it. Back to our ratios, opposite and adjacent is tan. So we'll write that down. Okay, and I'm trying to find the opposite. Opposite is the top, so it's going to be tan times adjacent. Write it down. Tan of what? Tan of 37 times the adjacent. Opposite is BE, that's what I'm trying to find. Tan of 37 times the adjacent, which I know is 46. On to calculator, cancel the last one. Tan 37 close bracket times 46, 34.7 meters. 0.7 because 6 is 5 or above, so it rounds up. Now that's not the height of the building. That we know now is just BE. So the height of the building is the distance BE, which we've just worked out, 34.7, plus the other bit that we're given, which we know is 23. So that's going to be 57.7 meters. And then the second part of this question, we want to find the angle of elevation of the top of the building from the point C. So that means we're looking for the angle that turns from the horizontal up until that line of sight up there. So if I call that X, that's what we're trying to find. So within this triangle, this is still the opposite, and this is still the adjacent. So if I just draw that triangle again, in case you can't see what I've done, I've got the triangle there now, B to D, which I know is 57.7, B to C, which I know is 46, and the angle, which is what I'm trying to work out. So when I label those sides, it's still opposite and adjacent, so it's still going to be tan that I'm using. So again, that's what I'm dealing with, but this time it's the angle I'm trying to find, so that's tied to the tan, so it's opposite over adjacent. Tan of x is opposite over adjacent. Put in what I know. Tan of x, opposite is 57.7, adjacent is 46. To get at the x, I've got to do the opposite of tanning, which is tan minus 1 of all of that. 57.7 over 46. On your calculator, type it as you see it. Shift tan, open bracket, fraction, 57.7, bottom part, oh, I've just typed in 577 there. Shift tan, 57.7, bottom part is 46. Move the bracket out, the cursor out, close bracket, equals 51.4 degrees. Okay, and the last one that we're going to look at is a different context again, in that here we're talking about bearings. So let's read the context. From a harbour, a yacht sails 4.1 kilometres north. It then sails 7.7 kilometres east before dropping the anchor. Calculate the bearing of the yacht from the harbour. So let's sketch that then. If we've got the harbour there, which we'll call H, north of the harbour will take us directly up our page. So it's going to get 4.1 kilometres in the north direction, and then it's going to change direction and it's going to turn east. So it's going to go from, if north is up our page, it's going to go from north to east, which is at right angles to it. So we're going to go east, and from east it's going to travel 7.7 kilometres. And from north to east is a right angle, 90 degrees. So that gives me a right angle there. And what I want to work out is if I was still at the harbour and I needed to get a bearing on that, then what angle do I have to turn through to get from north to look at the ship where it is. So I'm interested in this angle here, x. Okay, so that's the first thing that you really need to do with this question, is actually generate your right angle triangle and work out what you're trying to find. Bearings, you should know, are always measured clockwise from north. So in this case, clockwise from north is just the angle inside that triangle. So we'll name our sides. Okay, so our sides, if that's the angle I'm trying to find, then this side here is going to be my opposite. Here's my hypotenuse, which I don't know anything about, so it isn't going to form part of my solution, but I do know the adjacent. So I'm working with opposite and adjacent, so we're back with our tan ratio again. So let's write that down, TOA. Brilliant. Know that I'm going to be using the right thing. I'm trying to find the angle is tied to the tan, so it's going to be opposite above adjacent. Tan of x is opposite over adjacent. Tan of x is 7.7 over 4.1. Tan of x, sorry, now to get the x on its own, we need to get the tan undone, which is tan with a little minus 1, 7.7 over 4.1 equals, on your calculator, shift tan fraction button, 7.7 on top, 4.1 on the bottom, close the bracket, looks exactly the same, press equals, 61 point. Now, because the one decimal place is a 9, the one above it is 5 or above, that has to round up to 10, which means that to one decimal place this becomes 62.0 degrees. Okay, now bearings are given as 3 figures, and the 3 figures are an angle between 0 degrees, which would be directly north, and 360 degrees, which would take you back there. So the bearing will be 062 degrees. Okay, so there's plenty of trig questions there for you to get your head around. And on all the other past papers, you can guarantee that on paper 2, in the higher tier, you are going to get at least one right-angled trig question.